Hello everybody, welcome to another stream. How we doing? Hey there, 715-209. Welcome. How are you? So last stream we were working on a plan. Effectively working on this encoder system. We've written out the parser for it. The files look something like this. Bear in mind they do have syntax highlighting. We just use the C syntax highlighting. It just got some extra little features to it, but it's basically C syntax. And we'll be able to generate text encoders, and also there'll be like a versioning system in there with upgradability as well. So we're just planning out the whole system, just making sure everything makes sense before I carry on, because I'm at the point where details really matter, and I've done a lot of the things about the encoder system already. It's just, yeah, we need to refine out some of the details. So for the way we should approach it is write out the whole encoder system documentation, and with this we can just think about everything and hopefully get it all before we go back to working on the encoder system. Good, thank you. Awesome, good to hear. Yeah, not doing bad. Just been it's been working today. I got tomorrow off. So yeah, I was just working quite hard on something at work today. It was going alright. But yeah, that's about it. I got tomorrow off, which I'm spending with the boy, and it's raining tomorrow, unfortunately, but we can still obviously play around inside. But yeah, there's that one. So I've got two things on the list to do. There's a third one in the file, and there's a fourth one in my head. But I think these are the things that we'll work on today, and hopefully we get this documentation file all done. And then we can move on to actually like wrapping up on this encoder system and getting it all working, because I've been working on this for a good while. It'd be good to get on something else soonish. So we need to put the git commit hash alongside the version in the database file, just in case we have branching support later. So we'll do that one in a bit. This one is saying that the strat packed types, or the bit fields, these need to also support enum types, which we haven't done that yet. So let's put that down in the documentation file. So it should just be a simple case of, so we go through all the types. We go through all the data types here and what we support. So the variable length arrays, the packed type, which allows us to do like bit fields, but with like it converts from something into just bits within a certain range. So that's pretty cool. And then it generates code like this. But we also would like to say that it also supports maybe we can, if we've got time to do programming today, we'll maybe add this today. And enums. Field D, maybe only takes a few bits, like 3 bits or something. Right, so you can pack it down into 3 bits. That'd be pretty nice. And then you can obviously do ranged arguments as well with the enum. That'd be interesting. Yeah, so that's what it'll be like. Right, so we've added that to the docs at least. That's all we need to do. But maybe we get time to program, we'll actually implement that feature in the parser. Why C or C++? Any particular reason? Or equal over? Oh, well, C++ is far more complicated than C. You know, I wish C was actually more had less features because I only use a subset of C. But C++ is even more, has multiplies it by like 10 or more. It's kind of crazy. And I think some of the features actually degrade the experience. And the more you use a C++, what I've found is probably for every single C++ feature, you will use it and then you'll realize that actually the code would have been better if I just didn't use that feature. So I find that code quality is basically better because I don't use C++ at all. Because I will not make those mistakes. Like the problem is there's quite a thing in life that I do a lot. Is you always convince yourself of things. You know, I always convince myself like, oh, I've been a good boy. I can eat this thing, or you know, and C++ is one of those things, right? You know, oh yeah, inheritance will work well here. Pretty sure about it. Or oh yeah, templates are really good here, or whatever, right? And yeah, less features is better. Boss, I like to string. Thanks. Strings are pain to handle, see from my experience. The standard string is kind of cringe, right? Because it's not really a string. It's a string buffer. It's like a growable array. Heap allocates. It's sometimes got a short string optimization. Um, you know, it's a funny thing. Ada is really good, has a really good interface, but the strings aren't compatible. Really? Hmm. Yeah, you know, the null terminate thing has its pros and cons, right? Like if you make a hash table that has a string key and your keys are short, and you compare your keys in your hash table and you don't just compare hashes, the null terminated string is actually better than the one with an explicit size on it, because there'll be less yeah, because it's just less wasted memory basically. But you know, null terminated strings are a bit annoying. And sometimes, you know, we have our own little string thing in this code base. I call it a call string. But basically, you know, it's just a string slice or a string view, whatever you want to call it. So you have a data pointer and a size. And I can slice it up and trim parts of it and that, which I have used. But I don't really overly use strings in games. You know, also have a way to basically, with a custom allocator, I can use a format. I can format me a new string and just return it out. It's quite nice. Fuzzy compare and just hashing it. So, you know, strings ain't that bad. That's an alternative to C strings, but yeah, it's better. Yeah, but allocate sucks. Because allocate, you can't tell if something hits the end of the buffer. You can't tell if you're going to overflow a buffer. It's not defined, is it? Something like that. So you're better off just making your own linear allocator or a stack allocator. Kind of the same thing. Right, so validate that to the docs. That's pretty sweet. Enums as for bit fills or packed types. So we can just put an enum, pack it down, no problemo. That'd be pretty sweet. Right. So the other one will be this sort of git commit. Yeah, so maybe we need to start a new section of documentation. This will be the enc.db file. So, so we need to talk about how we'll get to this later, actually. Let me do the other ones I wanted to do. The packed type doc or the packed documentation specifying or upping the network target mode version. Yeah, but don't you just put that in up? Oh yeah, sorry. Yeah, you just put it into dev mode. Yeah, we have to put it into dev mode. Alright. So I think we should tackle this packed thing and then we'll go into the changes I want to make with this target mode system. Validation. Yeah, we haven't spoke about the validation system either. Validation. Yep. We need to speak about that. Encoder generator validation. Cool. So let's get this sort of packed thing sorted out. What is packed? Well, for networking, and I think so it's basically for struts. If you're not on GPU, you get this sort of packed so this feature. So what is Frost? Phoenix, we've not heard of Frost. So the main purpose, or like one of the things, for network target mode, the main purpose you really benefit from packing your struts into as small of a range as possible. Small of range as possible. All modern compilers. So on MSVC you push pop it, right? MSVC packed. I think you push pop. Yeah. It sucks. But we can do it. With include files, crazy. Right. All modern compilers support a sort of packed strut by that removes all padding. You know, really, things become unaligned, isn't it? See, are they portable though? That's the question. I think they are. Fundamentally, packing is too platform independent. Sorry, platform dependent. Suppose your pack strut has 8-bit fields in it, and consider some system with a 16-bit byte. You can't have a pack strut representing the data just by packing. What crap am I reading? Ugh. Yeah, so long as we use like fixed width integer types, this should be all right. Current packing alignment. Yeah. So right here, you push 1 on it, so it aligns to a byte. Yeah, we can do that. Oh, you're talking to the fossil bot. Fair play. I see now. I see what you're saying. Well, one of the compilers support the pack strut that sort of removes all padding between fields by aligning each field to 1 byte. Right? So yeah. So this comes at a cost of reading, basically, doesn't it? This comes at a cost of reading and writing to the structure as fields are no longer aligned to their preferred okay, there we go. That will do. So here we just want to say basically, you know, an example like this. Here's an example of using packed struts. So you just write hash packed, right? Voila. So say we did a U32 or a U8, then a U32. So I think the whole strut gets aligned to 1 byte as well. MSVC pack. What about the whole structure? If you change the alignment of the structure, you may not use space over the loss of performance. Yeah, but... yeah, I think it packs the whole strut. So the structure hasn't got the trailing bytes either, I think. It does make sense. Right, so you say this is at spans bytes 0 to 1, spans bytes 1 to 5, right? And here is it without the pact on it, 4 to 8. Cool. Right, so that's a good enough example. So let's get to the next section of what I want to talk about. So effectively, right, what is this encoder and decoder system used for? It's used for saving out files to disk, maintaining a version, and maintaining past versions so we can provide upgrade code, and supporting writing out to text files or binary files or both, text files for development and binary files for release. So there's these different kind of features, or there's these different sort of ways this encoder system can be used. There's also another way where it's great for sort of packing stuff down and unpacking stuff automatically and generating the code for that. So for the GPU side of things, hence why we've got this sort of target mode GPU, but effectively, see here how we've got these sort of bit fields where you can specify a float 32, packs into 24 bits between a range of 0 and 100, and it will create a function to basically unpack it from this bit field here. And I just realized I didn't, let me correct that for a minute. Let's added one with 3 bits. I need to take away 3 bits. Right, that's better. Yeah, so that'd be 32 bits. So now that makes sense. So it just all crams into that word there, and yeah. So yeah, we generate packing code and unpacking code automatically, which would be super handy for GPU stuff. So the way I kind of went about this, right, we've got this sort of versioning thing, we've got upgradability, we've got packing and unpacking, we've got and text encoding and decoding, and binary encoding and decoding. There's all these little features. So some of them are available for some things, some of them are not available. So there's a thing called target modes. Now, at the moment, the target modes, so at the top of your file, you just specify in your encoder file, you specify, hey, I'm targeting encoding out a file here in text mode, or a binary file, or text and binary files. But, it's got me thinking that we might want to target multiple things, right? Because there's another target mode of net for networking. This is just for making your own sort of network packets and stuff and packing code. Then there's a target mode for GPU, which is making your own GPU structures that you can pack down. And yeah, so here's the thing. We might want a GPU target mode, which is also a file. So we can also get some upgradability. Versioning and upgradability, but no text files, right? So this is where I'm thinking we should just go and change it to, you have targets, we'll just call them targets now. And the way at the top of the file, you just say, right, I'm going to target files and GPU. And because I've enabled these things, there'll be some features that will resolve based on those targets which have been selected. So these features are down here. I've already put them in here. Target mode features. So there is a feature called variable info arrays, CSON, which is the text file, versioning, version upgrade, and packed. So we need to change it now. Well, we basically say things are either enabled when you use this target mode, or these are unsupported on this target mode, right? So I think we should say, we should start off by moving the, so what I might do is move some of this stuff out quickly, because this file encoding and stuff is all in the sort of is in the file target mode. I think it's a little bit unfair, otherwise it should be moved out to its own section a little bit further down to describe these things a bit more. So it's file and decoding and encoding section. Text files are decoded. Sorry. Yeah, by calling the code generated functions after running this. Binary files are it specifically talks about files, doesn't it? Yeah, so we can still move this out. Is fully read into memory. Pointer to the real object. Right. We can rephrase that. Updating types for text files. Here's the rules. Updating types for binary files. So I think we can move that out. Yes, let's move that out and rephrase it. Hey, Devastated. Doing good, man. Doing good. Just been working today quite hard on something. At work. Just been basically building some caching system thing. So it's been pretty cool. Feel like I'll be able to provide some help to the team this way. So, it's always good when you get to do tasks like that. Provide value and improve something that's a little bit slow. So I got to do that today. Nearly finished it, but I hope to finish it when I go back to work. I'm actually off work tomorrow. Going to spend time with the boy. So just going to have a bit of a play. Just going to have a nice play. It's raining tomorrow, unfortunately, so we're just going to be stuck indoors, but yeah, it'll be good. But yeah, how about you? You prepared for the move? And I know you said it's happening this week, wasn't it? Maybe it's the end of the week. I think I remember you saying. Right, so let's move these things out. Generate code. What is this crap? Oh, yeah, that's that root thing, isn't it? Right. All right, here we go. So we'll grab that formats one in a bit, I think. Right, file encoding and decoding. So we should really say like encoding and decoding in general. So every binary file is fully read into memory. So what we want to say is that binary files, maybe I can just rewrite this all. So binary files are d/encoded in place in memory, or in memory in place using data structures generated by encoder generator. Defined that were defined in your .enc files. So we can say this saves or this means you can operate on your this means you can operate on your you can directly operate on the structures by converting the sort of opaque array of bytes, by casting the opaque array of bytes into the sort of structure you wish to decode. Something like that. So what we can say is for files, binary data is for the file target mode, this array of opaque bytes will be your root object defined with the hash root directive in your enc file. And then we want to say, yeah, something like that. And then we can say all VLA data will be stored directly after the root object. Right. So that seems to be a good change. And then we talk about text files. Text file. So, and there are text is only 4 files, right? The text files are decoded. Oh wait. Maybe we say binary files are manually right. So maybe there'll be like a way to, yeah, you probably will have like a binary file writer or whatever, which will allow you to allocate the root objects and then bump allocate the VLAs and get back offsets for it. Yeah, there'll probably be ways to do that. We should probably make one of those. Hey there, Foria. How you doing? Welcome, welcome. Yes, I'm ready to move. So it's packed this weekend, and we do the move in about 3 weeks. Oh, 3 weeks, right. Oh, I see now. I see. That's cool. Excellent. So maybe we will have a maybe we can say when encoding a binary file, you can use the binary file encoder structure, right? When encoding binary files, you will use the binary file encoder. All right, binary file encoder, where you will allocate your root object, and then you can bump allocate the VLAs and right and calculate the offsets correctly or something like this. Yeah. Where you will, so you'll specify like a range, the capacity for this file. Now, what's the maximum size it will ever be? Then, yeah, where you will specify the root object size and get a pointer to that. Then, while populating, you can ask the encoder, or you can tell the encoder, or you can bump allocate the VLAs using the binary encoder, and it will give you back relative offsets automatically. Look at that. That'd be cool. And then we say when you're done, when you are finished, you basically finalize the encoder, which will populate the version and checksum fields, right? Something like this. Yeah, we won't bother doing that then. Right, that's a good change. Yeah, that'd be pretty cool actually. Right, so this gets deleted, this gets deleted. We didn't talk about the text file though, did we? So we could say, so what we want to say is text files. The way these work is you decode the text file into a binary buffer basically. So maybe we use a binary encoder to decode the text into the binary file, right? but we'll do that internally all automatically. So we could say I was encoded by calling the generated functions in this. This enables us, or decoding text decoding the text files is achieved by decoding them directly into the binary file in memory. And so you can use the same processing code path for both, which would be pretty sweet. Cool. That's a nice change there to the documentation. So updating types for text files, these are the restrictions, right? Updating types for binary files, these are restrictions. So it's already binary files, right? Is text files for text though? But binary, whenever it's versioned, isn't it? This is kind of falls under the realm of versioning. So when you have versioning support, these are the restrictions. Maybe we need a versioning section. Where is that? We've already got one. Here, versioning. See, it's not just files now. It's kind of like, because networking also has versioning. So now you probably need to just call it data instead of file. Yeah, so maybe versioning needs to move out. This means you put it into that dev mode, isn't it? Yeah, I wrote it very specifically for that. Then this is upgrading. Down here. Yeah, right. Okay, let's move this out and we'll maybe fit the other thing as a subsection. Because this falls under updating. Because if you don't have versioning support on, then you don't have versioning support on. Then this stuff doesn't apply. These upgrade rules. Right, so when you've got versioning turned on, which means if you have either networking or file, target mode. I don't think we'll call it target mode yet either. We might change that. The versioning, we need to upgrade your file. You need to place it into dev mode, up to version number. Right, so we'll put in the and then we'll be like, how the final section will be like, how do you do the upgrades? Oh, sorry, how do I? So what is this? So this is like the workflow of actually versioning. It's just other Maybe we just get rid of the titles. How do I do versioning? Something like that, I don't know. Yeah, we'll have this. So, right, when data is encoded as text files, that can stay. Because this only works for files. You can do the following changes without updating the version. For binary data. It's not just files. Files or networking, yeah. You can make the following changes without upping the version. And these will, but the following will require updating the version. Okay. So, how do I do versioning? When you need to upgrade your file, that doesn't make any sense. When you need to make changes to your structures, to make, you can say breaking changes, but I just say make breaking changes to your structures. You will need to place your encoder file into dev mode. So you put the hash dev upgrade at the top, bumps the file version number. You'll upgrade from password. Okay, I just reminded myself of something. We need to add like magic number support, isn't it, really? We're doing these things. Yeah, okay, we might do that in a sec. This ups the file version number. Yeah, that's cool. This ups file version number, and all past data will be discarded. Keeps the same version number. You have to revert any assets made with this version. Let's amend. This is done like so. Right, so when we just specify this target thing, we're going to be changing it. B, you'll put like target and then dev, right? So we could say up here, versioning is only added when versioning is only the versioning feature is only enabled for targets file or net. Right, and then these are only applies when using targets file or net. Sweet. For files that exclusively export to a text file or binary file, the workflow is quite simple. Or binary data. You need to make changes that require you to go up a version. You put the file into dev mode. Yep, that's cool. Right, we support encoding to both text files and binary. When you support, yeah, that's both files, isn't it? Right, this still reads okay. My one concern is we haven't got the thing that specifies text or binary, the documentation needs to come before this, which we'll do in a second. Right, so it's not really for a binary file. Oh, it is for a file, isn't it? Yeah, for file on network. This is maybe for a file. Yeah. What did we do with that encoder thing again? Yeah, when encoding binary files, use that binary encoder, yeah. But for networking, you just convert an array of bytes into you can just cast a pointer and just start writing the data in. Yes, this is specifically for a binary file. So there should be like a magic number as well. So you can probably say hash magic and define a magic number. So yeah, so the version number is encoded at the top of the CSON file as an integer like so. For the text file, we have the following header. So you have a bit of magic in there. Should we put a bit of magic in there as well? Probably. The magic number, or the magic conversion number. So you'd be like magic ... The resist encoded as an integer. So the magic number would be a hexadecimal, 4-byte. That should be alright. Yeah, we've got to write how we're going to do that. The version number exists so you can avoid loading newer data. Yeah. The magic number ensures the file is correct, is the correct file format. Every generate data type for the file target mode will be prefixed with the version number. Right. Yeah, so we want to say if you target a file, every generate type when you target file will be prefixed with the version number. This is so we can support upgrading using data types directly. So we can just cast into the V0 example or V1 example when it makes sense. That's cool. Right, so upgrading, when the game tries to decode a file and version is older than the current one, the user creates their own upgrade function that will take the memory binary representation of the file and emit a new version into a new buffer. This new version will then be saved out and it's in its place. Then the standard manual processing of the binary file continues. Yes. That's okay. Right, so this is good. We've now got to move another thing out. So in this right, where is it? Target modes. Under the file section, we still had some more stuff in here. It's getting a lot clearer now. Yeah, there's only one more section, right? This formats section. So this formats section is like text, binary, or text and binary, right? So we should call it encoder formats, and we'll move it above the versioning, and we'll specify like, oh, you know, if you're this. I went past it, didn't I? Yeah, so this here. So here it is. So these are the encoder formats. A file needs to choose once, it cannot change. So I was thinking about that changing thing. We should probably support the changing thing at some point, but we might not have to do it now. So we could say can be supported in future. Changing can be supported in future. Changing to be text and or binary in the target mode directive itself. So when I say the word target mode, we need to get rid of the word mode. It's not really a target mode anymore. In the file target mode, target features. All right. Okay, we'll get back to that. In the target directive itself, right? So target file, so this one here, I guess we could say ... because we don't know what you put in here. We need to talk about the target directive as well above. So text file / ... right, can be anything. Data types are only exported as text, CSON. This should be used for things like configuration files, where the game, right? This is only supported. This is only supported when targeting file. When file is a target. Now we'll leave it. We won't bother putting that in because it's mentioned elsewhere. Data types aren't exported as binaries is useful for data simply instead for text. It should only be used for types that do not change that much. As with a binary file, you need to update the version. Right. When used with the versioning feature, it should only be used for types that do not change that much, as with a binary file, as with binary data. You will need to up the version for every time you want to make changes to the data layout. Data types are exported as text in development and release in binary. This works extremely well when your data types change a lot if they represent well in text form. Cool. Very nice. That's cool. So let's continue. So this whole target thing, right? Let's go to this target thing. The target specified at the top of the targets are specified. Maybe we should write out what they are. Targets Targets are ways of specifying how you wish to use this encoded data. How you wish to use the encoder system for this .enc file. Or ways of specifying how you wish to use with this enc file. When using targets, or when adding a target, so I don't think they can change either. We can maybe add it in the future. No, they can change. When adding targets, each target that is enabled will enable can enable features in the encoder system, as well as disable other features, as well as disable features because they will not be compatible with that target. So we'll say e.g. Text isn't supported on GPU. Cool. So we could say targets can be, I think they can be added and removed. It's not going to change much. Actually, it can. If you've got file, it changes the... Yeah, so I guess we could say targets cannot be changed. And maybe we could add the support for it in the future, but I don't know. Targets cannot be added or removed from an encoder file. You specify them like so. You specify at the top of the file like so. So we simply just do a hash target. So you could say file /GPU. So we could say at the top of the file, something like that. So we can say these sets of target modes means we want a file, a versioned file that possibly gets upgraded, that can be copied and used in GPU memory. And can be copied to the GPU and used there. So we have like an asset basically where it just gets, yeah, made and just can be copied directly to the GPU and directly used and versioned. Right, I wonder if we want to have ability to have a file one where you go, hang on a minute, this one just doesn't get upgraded, but we want the versioning feature. Like it's always breaking. No, this is okay. This is fine. And we could say we want, right, so the other one might be right, so we've got file, target, net target, and GPU. I was thinking of adding another one, which was memory, because you might want to just literally pack and unpack into memory. We want a versioned file that possibly gets upgraded that can be copied over the network. And then like this target mode means we want it to purely be operated on in GPU memory. Let's just be GPU, just to show you don't need all the slashes in it, right? Something like that. Cool, that would be pretty fancy. So let's go over these different target modes. I think we're gonna have a memory one as well. So memory just means you just want it to work in CPU memory. That might be very useful. We have an editor where we make assets, so that's this. Would also like to add more features without make changes without losing assets that have already been made. We'd also like to be able to use text files most of the time for development and so we can visualize the data better, and ship binary files of assets for speed and size reasons. In file target mode, when targeting when you target a file, So when you use the file target, a single encoder file represents a single file type. Yep, you must specify the root. Yeah, the root structure with that. Cool. The code generated. The generated code also contains a header field with the version, with the magic number, version, and checksum inside. Sweet. The network target mode, we're in network packets. You benefit from a lot from packing structures down before sending them over the wire. More magics. Hey Dora, how you doing? How you been? Yeah, gotta get that magic number in there. When reading writing packets from a packet buffer, these will cast the byte stream. Yeah, process them manually. Yes, they will. So there's no special structure for that. What else are we missing from here? Yeah, when you use the target, when you use the net target, a single encoder file, what does it do? It represents what? It represents the single. Well, everything's under the same version, isn't it? We haven't mentioned that. That's really what we're missing. It must be. Right. You also gain access to versioning. The versioning, so your packets. So your so you can communicate correctly with other clients on the same version. Cool, that'll do. So GP is another one. Been a while. Serding, yeah, serializing, deserializing. I do see. Yeah, so we've written a really nice encode format where we have our own little, like, it's basically a C file, but we parse it ourselves, and we don't support. Let's change that to strut. Yeah, so we support enum structures and unions. They just see like, but we also support these special packs types where we can pack stuff into like bit fields basically. And it automatically does the conversions and stuff, which is pretty cool. Yeah, so automatically does the packing for us based on some ranges. And we support VLAs as well. But we are currently, we've written the parser for it, and we're going to code generate text serializers and deserializers and binary structures that we can simply cast a pointer to and just start using. But I got to a point where I needed to define exactly how the system works, because I was getting to the point where I was stopping and starting and doing a lot of thinking, and possibly just getting to the point where I would have probably done some work and have to change it later. I haven't done too much of that yet. So yeah, we're nearly there actually. We're just finalizing the documentation now, but it's really been thought through now, and it's in a really good place. I like where we got actually. It kind of is like a multi-use system. It's very, very specific and unique, which is cool. But yeah, how's life been? You been up to much? What have you been up to, Dory? Right, so for GPUs, on the GPU we usually read the same data across multiple compute units. And this uses up space in caches. And memory bandwidth is also a problem. No, you need to solve. So packing stuff down as small as possible usually is the way to go for a lot of GPU algorithms. Manually run unpacking and packing code is error prone and takes time. And this is the main problem the encoder system solves. Since we want to support a wider range of GPU hardware, we are restricted to some basic types. Well, that's another thing as well. We didn't write in the VLA in the target features 4-byte types. Damn it. Yeah. All right, we need to do that. Also, the GPU does not have support for pointers. Oh, yeah, pointers. That'd be another feature. Pointers. So all the generate bit field unpacking functions are by value instead of by pointer. Done. So the other one is going to be called memory. And this use case, memory, you only really put memory down if you're going to be using it for packing and unpacking directly in memory, which is kind of very rare, but we might use it. Doc type is not fun, lol, but I gotta get it right. But gotta get it right for future. Exactly. Yeah, it doesn't feel like you're making progress when you write docs, and I'm not. But really, this does help a lot. It's allowed me to think about it. You know, yeah, it's definitely not the most fun thing, that is for sure. But it's so close to being done. And I guess it can be there for future to read up how the system works as well. But it's not going to change much. This when writing, so when what should we say? When you are writing data infrequently, the same data infrequently, but reading the data, the same data multiple times, and maybe multiple times over many cores across many threads. You might benefit from packing your data structures right down to help with the to help to utilize the cache more effectively. The cache more effectively. So this is what it is for, basically. When you're writing out data infrequently and reading the same data multiple times, and maybe multiple times across, and maybe across multiple threads, maybe across many threads, you might benefit from packing your data structure right down to utilize the cache more efficiently. Let's just use the memory. That's the use case. Right, so here we go. Let's get these target features done properly. Features are aspects of the encoder system that change depending on your target mode, depending on your targets. So VLAs, let's put memory in there. To be cache friendly. Maybe there's a better way of saying it. To be cache friendly. That's definitely more a cache friendly way of saying it. Benefit. You might benefit by packing your data structures to become. You might benefit by packing your data structures to become more cache friendly. Boom. There we go. So VLAs. We're going to change a bit of the terminology here. Well, I could call it the mem rather than memory. Right, so what's the way of saying it? VLAs. They're only really supported for files. But could it be useful for memory? VLAs, you might say if you pack it down, you have a root type, and you encode it using that file encoder. I don't see the benefit of that. So what we want to say is when you use, so VLAs for net, so VLAs are unsupported. So what I want to say is there's a few different ways of saying it. There's unsupported, there's enabled, unchanged. So I guess there's so we probably want to say there's three different types of each feature can be enabled, unchanged, and unsupported. So maybe we could say disabled maybe. Unsupported sounds stronger though. So feature is enabled for this target unless another target says it's unsupported. Feature is so you just say supported. Features supported. Maybe we should call it supported and unsupported. So for networking, if you have VLAs, it's a file that gets sent over the network. Right. If you have file and memory, it basically does nothing. It doesn't mean anything. Yeah, but right, okay, I see what you're saying. Right. So maybe you just say it's supported, but it's not. Yeah, let's just say feature is supported. And left unchanged by this target. And then you say unsupported feature is not supported and is and completely disables the feature. Right, that'll do it. Cool. So it's unchanged. Variable length arrays inside struts are only supported for the file target mode since they only work. Already support now. Only enabled by the target file. Since they work by encoding and offset for where the field is. For files, it's very easy to achieve since we bump allocate the array's root object. When just used with net target mode, the package size is only 64K, so over 10x work out better. And for GPU buffers are singly typed, so supporting it will only really work if it is some untyped buffer and reconstructing it. I don't see any use case for this at this time. Yep, that's true. Right, CSOM. So CSON is our custom C-like JSON. So let's bring these boys and girls over here and we'll change it around. So it's enabled for files unchanged and unsupported for GPU. Are only really useful in serializing out a file. Yep. Versioning. So versioning is enabled when using a file or networking. It is left unchanged for GPU feature. Sorry, for GPU target. And memory is unchanged as well. File needs versioning so we can preserve assets. Net needs versioning so other clients on the same version can ensure that other clients are on the same version so they can communicate. So we want to say GPU and in-memory don't really need it unless combined. And memory targets alone. Purely work with types that are released in binary code, so no versioning is needed at all, unless you combine it with the file or net target. Very good. Yeah, this is working out good. Shoot. Right. Version upgrade. So version upgrade is only used, I think it's enabled the file. For networking, it's unchanged. So if you have file and networking on, it obviously be enabled. GPU unchanged and memory unchanged. The main purpose for file target for the file target is assets. We have mainly in the is this English? The main purpose for the file target is assets that we mainly have. That we have mainly. The main purpose for the file target is assets that we mainly edit in the editor. We need to be able to edit these types easily while developing new features, but also provide a way for us to upgrade old assets to new versions. Net will only need versioning. Ensure other clients have the same version. GPU types purely yeah, so no version needed at all. Packed. Right, so packed actually can be supported for file and net, but they are completely unsupported. Should we say packed is enabled for memory as well? Yeah, but they're completely unsupported for the GPU type. So for net target mode, you're really benefiting from packing structs into small range possible. All model compilers support packed and removes all padding between fields by aligning. Yep, each field to 1 byte. The cost of reading and writing to the strut. Yeah, this comes at cost of reading and writing to the strut as fields are no longer aligned. That's cool. Right, GPUs do not obviously support it. Right, so 4-byte types, we kind of want a bit of a... Let's just steal these two lines. Pointers. So 4-byte. So we want to say like non 4-byte types. Enabled, unsupported. Since we want to sort a wide range of GPU hardware, we restrict basic types to E32, this, that. Bit fills always be E32. Cool. Non 4-byte types. Same for this pointer one here. Pointers are enabled for files, networking, and they're unsupported for GPU. Yep. So the GPU does not have pointers. Well, it does, right? But only on the latest and greatest hardware and things. You know, we'll progressively get it more in the future, but I think for this game we won't use them. Yeah, so for bit fields we pass by value, which is fine because everything is inlined. So pointers are unsupported. GPU. Cool, so I think are we there with the documentation? We're pretty close. We've still got to do... Alright. That's really turns out well. It's a lot of docs. We've still got to do the magic number. We'll talk about that. Files. The file target modes also need a magic number field. Below the target, probably. Yeah, so when you use target file mode, so every file or maybe the magic goes in the target. Nah, I think I'll have a bit of a hash magic. Every file needs a magic number to you know, for checking that the type what's the words we used earlier? Yes, the correct file format. For ensuring that the correct file format has been passed. For ensuring that the correct file format is being processed. So you know, you specify the magic directive below the target. So we'll just do that here, right? And it has to be only for file. So we'll do something like this one. The magic number is always a 4-byte hexadecimal number. So Yeah, you just do, you know, for file, binary, magic, 0x, um, can I do like a string to hex? Let's say hmm. Let's just do that one. So that's in like big endian order, but it doesn't really matter. Yeah, there we go. That's all that is. You know, by doing it in hex, right, it means that you can do all sorts of characters in there. You don't have to just do ASCII characters. You can do the ones outside the ASCII range as well. It's quite nice. Cool. So there's the magic number. What else are we missing? There was the validation. Do I need to write about the validation? Probably don't. Let's just not bother with that one. So there is the database file. We do need to plan how this is going to work a bit. So we've already got the encoder database. It's a little bit different how it's going to be. So if you look at these structures, they are repeated. They've got like a hash v, v0, v1. So that's like version. Now, I think, right, so we've still got versioning, but that's only enabled for files. So we should probably have so we should probably say version 0, and then it does all the version 0 stuff. And then you do version 1, and it does all the version 1 stuff, or something like that. So they all get put into the correct places and things. And we'll probably also put the commit hash in here as well. Probably put it as, you know, the shorthand commit hash. So we could possibly merge them in the future. So we want to say when the file target is being used for a .enc file or net, because there's versioning. Does it? Yeah, because there's versioning. The versioning feature will be enabled. This is achieved. This is achieved I always don't know if I was spelling that word wrong. Good, I am. Right, this is achieved by adding the encoder generator with a database file. This is achieved by encoder generators with a database file that is auto-generated. It contains the so it contains the edited declarations before it contains the declarations so that validation can be performed and errors can be reported if the user makes changes that are not allowed. Then when dev mode is enabled and the user makes edits, the database file will be updated accordingly. Sweet, that's pretty nice. So that talks about the validation side of things, actually. But we also would like to... Hey, Zlad. And if the player is satisfied with the game, does it really matter that the satisfaction comes from genuinely overcoming a challenge or from gameplay cleverly rigged by the developers? Bwom, bwom, bwom. If the player is satisfied with the game, does it really matter whether satisfaction comes from generally overcoming a challenge? Gameplay cleverly rigged by the developers, right? Huh. Right, I see what you're saying. So kind of like a casual game versus a more hardcore game. You know, game is an art form. So and people prefer different types of art, right? Obviously, games can also pick on people's can be very psycho they could play on your brain a bit and get you addicted, right? As well. Play on that sort of thing. But there's games are built for different types of people, right? People who casually pick up a game and play it, kids who don't really know much about playing games at that point in time, people who have played games for absolutely years, right? So yeah, it just depends on what the game is, what the game is targeting, really. Where do I stand? Well, these days, I don't like games which are overly difficult because I don't have the time to sit there and practice and get like super good at it. Like, I've never been that good at Dark Souls, and I tried to play it, and I've tried to play it a few times actually, and yeah, it would just learning the bosses is just not what I call fun. Um, yeah, typically I want a game these days where I don't think, because I do a lot of thinking, during my work hours and obviously after my work hours here, and I just like a game that I can just sort of pick up and play that is a little bit more casual, but also isn't super easy, right? There's a balance there. Um, yeah. So I'm not necessarily like a hardcore difficulty player. Um, yeah, I think there's a balance to strike there. Obviously, you're always going to get people who are really into the hardcore side of things because that's what typically men do, right? I'm the more hardcore man type of thing, right? It's a very ego thing that there is always going to be an audience for. But it's not my thing these days because I don't primarily play games anymore. But probably may have done it in the past. Um, yeah, sometimes games are just good because they're just different, you know? You know what I mean? And they just provide this different experience, and you're like, wow, I've not really seen that before, and it really just catches you. Um, it's a piece of art at the end of the day. Um, yeah. Deep House. We went from Stone Rebel to House. What is YouTube on? What about you, lad? Where do you stand? Hey there, Kept Pain. How you doing? What are you encoding slash decoding? So, we're building an overarching system for generally encoding and decoding files for level files, for instance, for having entities and encoding them into a level file. So you can save and load levels, build them in the editor, and voila, build them as text files in development, and then in release builds, they'll be binary. But also we are going to have a editor for some models. If you've seen the game so far, yes, it builds and runs. Look at that. What we have is a low entity system. These white boxes are regions. The entities live next to each other in memory in the regions. And here is an entity moving between regions. And the entities are made out of spheres or ellipsoids, shall we say. And there are some rendering bugs, but there we go. It's the flickering. So we're going to be having an editor where we can build these custom ellipsoid mesh things within the editor. So I want to be able to save and preserve assets. So we're going to be encoding this to disk, and these may get directly loaded into GPU, so they have their own restrictions, like they have to be limited to 4-byte types. And, well, that's some of the assets, right? And sometimes, right, on GPU land, you just really benefit from packing and unpacking stuff into as small space as possible. So this whole encoder and decoder system solves all those problems with one system, and different features go on and off. This is what we've been planning over the past couple of streams now, is how do we get all the nitty-gritty details sorted out so we can finish off this system. This is a little encoder file Well, we parse it, generate some type information, and we'll generate the text decode and encode functions from it per type. And it's basically C syntax, but it also supports packing and unpacking basic types into bits. So like bit fields, but they're ranged, which is super nice. So yeah, that's what we're encoding / decoding. If you have any more questions, feel free to ask some more, because I'm not sure if I covered everything. Maybe I did, maybe I didn't. Yeah, that's what we're working on. Yeah, so we want to talk about the version now. Right, when you have versioning enabled. Right. Oh, sorry, upgrading. When you have the upgrade feature enabled via the file target. You know, the database will also preserve all past types from previous versions of the file. Amazing. But unless the hash dev no upgrade was used, that completely removes all past versions. Look at that. Yeah, that completely removes all past versions. That's cool. So what is next? So we want to say versions are specified. One more minute. The database file, the .enc database file, looks identical to the .enc file, but everything is explicit. Every sort of value is explicit, and some extra directives exist. That's, yeah, there you go. Directives exist. Right, that's cool. So one of those directives is this hash version. Right. So when it doesn't make sense if you put it in versions. Yeah, it does. Right, when versioning, when upgrading, so upgrades cause the upgrades cause the types to be declared multiple times once for each version they exist in. The following the hash version directive acts as a separator acts as a marker for where that version's types begin. So you might say, here's an example of the file. So you'd be like, boom, hash version 0. Then you declare some types. Okay. The git commit hash, or the, did you call it a git commit short hash? Yeah, something like that. Or the short git hash is encoded in the version directive. So we can possibly support branching in the future. Branch in the future that will merge branched versions, or if we ever need that. So yeah, we'll, whatever a short git hash is, should we get one? Git log. Forgot what they do. Git, I think it's usually 10. Hey, Campaign. Can't remember if I asked before, but have you heard of Dwarf Fortress? What do you think of a game like that? It's something algorithmically and programming heavy versus something like an RPG. Yeah, I've seen Dwarf Fortress. I follow it actually. I've not played it before though. You know, I do like the guy who makes it, the main programmer, Tan Adams. You know, his brother as well. But you know, Tan's a pretty cool guy. I don't know if you've seen on YouTube. Like I always, whenever I see a Tan Adams video, I'm on that. I always love interviews with Tan. They're good. But yeah. What do you think of a game like that? Yeah, it's pretty cool and interesting. Yeah. You know, how it's all procedurally generated and how in depth they've gone into simulating things, even though there's only, you know, like they simulate like limbs and things. But you don't have a way of actually seeing it, right? You have to read about it, which is interesting. And because they did a text-based version for so long, when they added a feature, it didn't really require art assets, so they could add it very quickly. That's pretty cool. But yeah, I think it's an inspiring game. It's pretty great what they've achieved. I've just not really played it too much, or I haven't really followed it too in depth. But yeah, it's been a while since I've last looked at it, to be fair. How about you, Campaign? Have you played it much? Something more like a sim, and how your world will react with itself. It'll be fun to see how it all comes together. Yeah, exactly. Yeah, so that's one of my inspirations for maybe making this game that I'm doing. Be more, have this very heavy interaction, and have it be more alive. I think a lot of that inspiration probably comes from Dwarf Fortress, but I don't know. We have to design the game out first, right? But that's one of my initial thoughts is like, I want this game to be an RPG. And maybe procedurally generate it. Maybe we'll design the world and just have it all run from that base thing. Or have some procedural elements of the world. But yeah, making the world feel alive and having the characters be more, the AI be more complex. Maybe that's something we do. We'll see when we get there. Yeah, it's fun. I don't like the 2D aspect as it's not immersive, but it's fantastic. Yeah, some of the stories that people have that have emerged from there, people tell are quite funny. Yeah, and it's great they got to release it on Steam and actually make money from it eventually, which is great. Very happy about that. Right, so where's the short? Right, short. 1, 2, 3, 4, 5, 6, 7. So 7. Maybe we'll do 8 because then it fits into a. That's a U32, isn't it? Yeah, that'll be a U32. We could do a U64, but it'll be a bit long. Will it? Well, it'd be like 16 characters, wouldn't it? It ain't long. Wait. Yeah. It'd be 16 characters. So, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That'll fit into a U64. Yeah. Let's do that. Let's do 16s. We can always trim parts off of it if we want to do a shorter one. It's just safer that way. 1, 2, it's hexadecimal, right? You can see it's not got any other characters other than A, B, C, D, E, F. 1, 2. Can I do something like that? Oh. Right. Sod it. Let's just copy that and just A. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I could have just done that another way, but you know, by doing 16 left or whatever. But anyway, we did it now. Cool, the git hash there, which is hexadecimal, very nice. So you define the types here, you know, types are declared here. And then version 1. Yeah, that'd be pretty legit. Right, so I think that's all I really want to say for the docs. It's getting quite good there. Yeah, I think the docs are in a really good place. So, why don't we do a bit of a status and do a little bit of a commit. I want to commit the docs. We've thought about everything now. It's not git commit. What is that? Yeah, so, you know, complete encoder documentation. There we go. Very nice. So now we can get, we still got some time left to do a bit of work, I think. So we'll add support for those enums in the packed types. So encode. So we want to be able to basically specify the we want to be able to specify like ent type and then pack it down into like so many bits. So we'll just do this parsing of this, right? And you could optionally have more stuff that comes after, or just it stops there. There's just some ent type. So we can pack enum values, which would be pretty nice. There's a game called The Wayward Realms, which is kickstarted, heavily procedurally generated from the programmer of Elder Scrolls 2, Julian Lefay. RPG style virtual game master. Oh yeah. I think you mentioned this before, actually. Maybe. Let's watch a vid. In a world. I don't know. Welcome to the archipelago. Nice, it's all like 3D and everything. Yeah, rendering is like quite strange. It feels like the rendering is like, this looks like pretty low. Like pretty basic. And then like you get here and then the rendering's like a little bit better. Like the trees make it look a lot better, but then like, you know, this all looks like detailed and everything. But yeah, it's always strange when games the detail sort of varies a lot. It needs to be consistent. Like it could be consistently terrible. That'd be okay. So when the detail changes. Nice. But yeah, I don't know, like it's interesting. So you're saying this is completely procedurally or heavily procedurally generated, right? Is there like a base world? That'd be pretty cool. That's what you want really sometimes, is a game to do that. It would be cool if we did that. I'm not sure though. That's what I wanted to do at least. See, the problem with going with that approach is that it could be a pain to debug, right? It'll be a pain to make, depending on what you procedurally generate, it'll be a pain to make certain things feel like they belong or feel like they make sense. And also, when you procedurally generate, you have to create all the rules that you want to come out of the system. So if you want, like, you can't have the most crazy thing happen unless you program the most crazy thing to happen in this procedurally generated thing. So when you make your own story, you don't have to have this rule-based system there where these crazy things can come out from. You're just making the game, so you could just script it exactly to what it needs to be and how it's going to happen. You know. So, but yeah, it's definitely something I'm going to consider though when I get to thinking about the game design again. Your look at Steam page is a lot more descriptive, but yeah, heavy system, cool. Very alpha, but huge world and whatnot. Amazing. Making a procedural system feel handcrafted would be a huge challenge. Exactly. Yeah, just how stuff sort of like forms as well, like a world and everything. Yeah, just quite difficult. Hey, Master Agent, how you doing? It's been a good while. How are you? How's life been? Give me the DL. How's life? Right, so we're gonna parse this enum, which we already do, and we're going to make it a packed type. So let's fit it in that encoder system, see if we can get it jammed in there. These are some to-dos which we might not need to do anymore. We'll see. Packed type. So packed type, the underlying packed type, it could be as a basic type, or it could be an enum. And if it's an enum, so really this should just be a type pointer. This is the unpacked type, or it's an enum or basic type. That's the new thing. All right. So basically, unpacked type. Ooh, that's been a buggered. If type packed t equals type packed unpacked type. Array of t kind equal basic, type kind basic, meaning it's just an int or a uint or a float. Then we go full ham, t basic on that one. Then else it will be a enum. So for that one, you just return type ident. Cool. Wait. Type ident mixed with some of this lovely. What is all this? T basic. Cool. What else? Yeah, so we want to return, so a pack type would be the enum string there, the t ident. Dot star string. Then float. No float. We should really put the two strings in there. So these are the two strings of the enum values. How are we going to get those? Well, the version... No, we'll put them as integers. Because they cannot change. The numbers cannot change. Oh, be careful about that. If the numbers change, then they can change when you do the dev mode thing. So you do the dev mode thing, and that will mean that when you parse these, they'll get updated. Something like that. Yeah, I think that'll be okay. Life's finally turned back around. Awesome. Started on my first day today at the new job. Amazing. 7 months of quick noodles wiped away in an instant. I wish. By the way, first day was nice. That's very cool. I'm glad to hear you got that job. Yeah, I remember you just getting that bad news. I'm glad you managed to finally get a play. Yeah, it's really, really bad, isn't it? The industry. You know, like some places are obviously still going and very fortunate still have my position. Um, but yeah, it's been pretty rocky the past couple of years or yeah. Like if someone got laid off, just trying to find another job with everyone else seems so bloody hard. I think a happy medium would be running a manual pass over a procedure generated world, making making the world make more sense and making it feel handcrafted whilst shortening the time to create the world. Yes, yeah, it's interesting. I think some of the when people do like maps, like they'll procedure generate a map and they'll be like, oh, that one looks nice, and then they'll sort of like go from there basically. Yeah, or you could go the other approach where you handcraft lots of things and you procedurally generate aspects of it. But yeah, I think combining it is good. Another good approach. Yeah, super awful. I have people in my LI, not sure what LI is, who have been actively looking for a new role for almost 2 years. Oh my damn. Yeah. Yeah, sometimes you just gotta go to another industry, but it's not good. Because once you come out of the industry, you have to get back in again, you know? Oh, LinkedIn. Right. Ouch. Yeah, it's very sad. Right, can we support? Yeah, so we put it into a dev mode, then the number, so you parse it up. The numbers always match. Yeah, but then you change it will just copy it all over. Yeah, it will work. It will work. That'd be amazing. Just be a uint then. Uint, then uint. Oh, it's gonna be legit. Maybe not uint, because it really depends on the enum type. So depending on the enum. Ooh, isn't that interesting? Basic type, just call it basic. So if t kind equal right, I got this. Oh, I messed that up. Right, so basic equal t basic. Then if it's an enum, then basic equal t enum underlying type, and that's a basic type. Then this switch statement just works, and we don't need to do anything special. Pretty legit. Nice. So that switched that one. Pretty cool. What else? Right, so this is the actual parsing code where we will parse that initial type. And then, so I think, right, so if type is basic, it goes into here. Right. So really we should be able to find a type in the type table also. I guess return to then, that's good. If type then return. Ident that if type is basic type. Right. But didn't we put it in a type table anyway? Yeah, just did some hashes, but I think those are in. Those can just look up in the hash table. Something like that. Else if type, return type. Right, so we get the... If type is... If type is basic... I don't know why I need to do that. You can just do type kind equal type basic, or type kind equal type kind enum. Then we can go into here. If it's got this sort of bracket, then it's the packed type, and you start in the packed stuff. So then you say, all right, you just got to be careful. Unpacked type. So we store in a quick local, make a new type, call it a packed type, zero it, set it up. The whole thing's zeroed though anyway, isn't it? Yeah, don't be a fool. Right. So, B, after you parse the B, you don't necessarily need, if it's an enum, you do not need the rest, so you could actually skip it. Yes, you don't need a minimum for an enum. And then for an enum, we also want to say, so Boolean is enum. And I give pointer. First off, hoping how far away from implementing the gameplay. Probably a year and a bit. Yeah, probably like a year. More than a year and a half. We're working on an editor first, and then working on, because I'm working on this in my spare time, right? 3 days a week. And I don't really get, I get like 4 hours every time I work on it. We've got some sort of custom rendering of ellipsoids. We're going to be building an editor so we can build a world, and then go back to rendering, finish off the rendering, make it look better than it already is. And yeah, there's some glitches. Yeah, we're working on the game technology at the moment, just getting the engine together. A whole new workstation from the deployer, nice, it's a beast. Literally 8 times more memory than my laptop, using for personal projects. Yeah, I remember when my PC from work came over and just sent this massive thing, and it's just like super powerful. Good times. But yeah, so we're working on mainly some editor support and then back to rendering. So we're going to be able to make assets and then make them look good. And then we'll get to some gameplay. Because part of this project is a personal thing for me to learn, but also, yeah, learn more about graphics and things because I'm a graphics programmer as my full-time job. So I want to like learn more about it and have something to tinker with. But also, so it has taken more of a graphics orientated approach, this project. But yeah, when we get to a good enough place, we'll actually start designing the game in more detail. I've already got an idea for the game, but obviously not sticking to anything too concrete yet. What do you do at work, for example? I work on 3D graphics, so shaders, platform abstraction stuff, and what else? Yeah, stuff to do with GPUs and rendering 3D stuff. Yeah, write code, C++, CPP. Don't show the motherboard, but it has Ryzen on. Oh. 128 gigs of RAM. Nice. No, I went for NVIDIA. It gives it away. You can also check my Twitter or X if you want to call it that these days. Yeah, still at MM. Yeah, I've been there for like, yeah, 3 years and 4 months now. Maybe 3 years, 3 months. Yeah, it's really cool. It's a great place to work. Super happy. Have a lot of fun every day. We need to get the basic. We could probably encode the basic in there as well. I don't know why I'm being so... Nah, we'll... Unpacked basic type. We'll probably do as a little bit of a local. That will make a ton of sense. Unpacked type, enum, underline type. Whereas if it's a basic type, it'll just be coming from basic. Right, so now that's a lot more accessible. That means in that toString, not toString, what is this, Java? Type string, wasn't it? Something like that, yeah, that's it. So that means we could just say basic equal basic, right. Nice, that's cleaned up. Pretty good. So let's get back to that actual parsing code, parse type. So that gets set up nicely. We might as well make a little one called basic as well, you know. Little local, cheeky local. Basic. Yeah. Right. So now the thing about enums is you don't need to specify a range for them because they already have a range of a min max value. And yeah, sometimes when you don't want to parse a number, sometimes you want to parse the actual value, isn't it? So that needs to be done as well. Yeah. Anyone who does some crazy stuff with dreams would love to work there. Yeah, Dreams was a very, very amazing project. The things people create in Dreams is freaking with freaking DualShock controllers insane. Yeah. Yeah, Dreams was like a really interesting package. Like had the whole sculpting thing, ran on the PS4. Um yeah. And just the way people managed to make stuff that looked like the quality that they looked as well when they still ran on a PS4. Like and it was made with the PlayStation controller. Very interesting piece of software. Um, right, so I think we might put a pin in it there today. So we've got the documentation done now. So it's going to be a case of completely, well, not really completely, starting work by taking that documentation and completing everything that the documentation says exists, and follow all the rules. So we've already got the encoder file parsing up. We've got to add like unions. We've got to add like that, finish off that enum support thing for the packed type here. Well, we didn't quite get it done. But yeah. Then we've got to support like that target mode thing where you say target file slash GPU binary mode, right? Stuff like this, and you say I need a magic number. So we need to add support for stuff like this. And yeah, just start testing it all out and get it working. Then after we've got the whole encoder system, parsing this file, verifying everything and all the different configurations work, we can then get around to the code generation side of things and get that working as well. Right, so this will be carrying on Thursday at 7:30 p.m. GMT +1. So 4 hours ago but on Thursday, and then kind of 4 hours ago but on Sunday as well. But yeah, let's find someone to read. We're on a GPU driver. Okay. It's funny the little projects this guy does. It's just so funny. I wonder. It's obviously going to be some software development thing, isn't it? Sorry, software renderer or something. Maybe. Right. Have a good rest of your week. I guess I'll see you all on Thursday.